Good evening, Neha and Harshit. Okay, so please put on your screens. All are here, except Bhavesh. Good evening, everyone. Turn on your cameras quickly.
Good evening, ma'am.
Good evening, ma'am.
So, yesterday we did 5 of the properties of states of matter, and rest 5 were your homework. So, shall we start discussing?
Yes.
Can you tell me what was the next property in series? Diffusion, compressibility, or what?
Ma'am, density?
Density was the next property, okay? Harshit, tell me about the density of solid, liquid, and gases.
Ma'am, solids is more than the water.
Just a minute. Solids are
More than the water density.
okay. Then density is greater than liquids. You mean to say this?
No.
Hmm.
Liquids are like medium, low.
Just hold on. Let me put the heading. Solids, liquids, and gases. So first solids, you are telling me that the density is comparison to liquids. Can we write something about density of solids is high or it is low?
High.
Density of solids is high. Now for solid, for liquids,
Ma'am, low.
then what will you write in gases? Least?
Lowest.
Low. Least, okay. Fine, that is also fine. Or else you can write like in liquids it is moderate and gases it is low.
Good evening, ma'am.
Good evening, Adyakshan. Yesterday absent, Adyakshan.
Yes, ma'am, I was absent.
Why? Why?
I was not there, ma'am.
Okay. Uh, Tell me next property. Okay. Next property. What was it?
Um, compressibility.
After density, what was the next property? Diffusion, I guess.
No, ma'am, diffusion is before density. Compressibility is it?
It was compressibility.
Yes, ma'am.
Okay.
Um,
Hmm.
solids, we can't compress it. like not easily.
Hmm.
Liquids, we can slightly compress it.
Slightly compressible, and that too depends on the container in which we have kept the liquids. If you are putting the liquid into a solid container, then it can be compressed,
Yes.
right? So okay, we can write slightly compressible. We can write like this.
And gases are highly compressible.
Highly compressible. Slightly compressible. And gases are highly compressible. Neha, next property.
Yeah. Ma'am, rigidity.
Okay, rigidity.
Rigidity of solids is high.
Okay.
Ma'am, rigidity of solids is high.
Correct.
And liquids is medium, moderate.
Moderate. Okay.
And gases is low.
Mm. Low, or we can say no rigidity at all.
Yes.
And by the rigidity, if I ask you about the fluidity, simultaneously tell me about fluids also. Can solids flow?
No, ma'am.
That is, and cannot flow at all.
Okay.
Can liquids flow?
Yes, ma'am. Can flow.
And can flow. And about gases?
Ma'am, they flow.
They also flow, and very easily.
Yes, ma'am.
Fine. Rigidity and fluidity. So that's the 6th point. 7th one is compressibility, and 8th one is gas. Okay. Next, who will tell me? Harshit, you again tell me, please. Next property.
Mom, the last one is kinetic energy of
Last was kinetic
particles.
energy. Before that,
Before that is rigidity, ma'am. Before that is rigidity.
I think we have missed diffusion in between. That's
Yes,
okay.
ma'am.
Let's discuss about diffusion. Their ability to mix with the other substances.
Yes,
It was
ma'am.
somewhere in between. I don't remember the order, but yes, diffusion was there. Harshit, tell me about diffusion.
Ma'am, diffusion solids dissolve, diffuse.
Diffusion of solids is? Can solids anyhow get mixed into liquid?
Yes, ma'am. Sometimes
Example?
like salt, sugar.
Okay. So we can write can diffuse into liquids. Can diffuse into liquids. For liquids, what will you say?
Ma'am, both can diffuse and cannot diffuse. Like oil can.
No, listen. Then we are not discussing here about the miscibility and immiscibility. Any of the liquid, if it is able to mix or if it is able to diffuse into some other liquid or solid liquid or gas, then in general liquids will be called, yes, they are diffusible. Okay.
Ma'am.
So we should say that diffusion is higher than the solids in liquids, isn't it? Because they mix easily. If we mix two liquids together, it will be very easy to mix them. We means not even need to stir them for a long time.
Yes, ma'am.
Diffusion in liquids is higher than solids. For gases,
Ma'am, yes, ma'am. They can diffuse.
they can diffuse, and in fact, gases are highly diffusible. Means we will keep searching the place where the gas has been diffused. Means a balloon, inflated balloon, a tightly tied balloon. Okay, no space we have left for the air to release. But still, after 3-4 days, you will find that the size of balloon has been reduced automatically. Isn't it?
Yes, ma'am.
So without any space also, it is diffusible. So we can write highly diffusible. Highly diffusible. As the particles move randomly at high speed. In the bracket, you can write down as the particles move randomly at high speed. Next, who is gonna tell? Adakshin, can you try? The next last property of solid, liquid, and gases, that is kinetic energy of molecules.
Hello, ma'am. Now you can hear me? Hello?
Yes,
Hello?
I can hear you. I can hear you. Tell me.
Hello? Hello?
Adakshin, can you hear me?
Ma'am, I can't hear you, ma'am.
Can you hear me now?
Yes, ma'am. Now I can hear you.
So tell me about the kinetic energy of solids, liquids, and gases. Kinetic energy of particles.
Ma'am, didn't understand, ma'am, the question.
Dear, we are discussing the properties of solid, liquids, and gases, and simultaneously we are looking at the difference in between these properties of the three states of matter. These states of matter are not only the three. Basically, there is one more state also, that is plasma, but at your level of grade 6, we are discussing these only. So kinetic energy of particles of the solids. Suppose if we provide heat to solids, any solid substance, what will happen? Do the particles of solids start moving here and there?
Yes, ma'am.
Oh, then what about liquids? If we put water to boil on a pan, does it shows an emotion?
No, ma'am. Yes, ma'am. Yes. Sorry.
It shows motion.
Yes, ma'am. It shows
Okay.
me.
And if we provide heat to a gas, then
No, ma'am.
it does not show.
Yes, ma'am. It does not show.
Any changes anyone like to make in this statement? Anyone else?
Ma'am, gases.
Hmm?
Ma'am, gases can expand, ma'am.
Gases can expand on providing heat. That is, the kinetic energy of particles is the highest.
Yes, ma'am.
Maximum energy is exhibited by the gas particles. What about liquids?
Ma'am, liquids also expand.
Liquids also expand. So their kinetic energy is high, but not higher as gases, and not least as solids. So we can say, okay, if we begin with the solids, then we should say that least energy exhibited by solid particles. Okay. And liquids is higher than solid, and gases has a maximum energy. Right. So let me write down.
Ma'am, petrol expands? Ma'am, I think so. Petrol, ma'am.
Every liquid expands. It shows behavior.
Okay, ma'am.
I've written in short, K dot E means kinetic energy. Okay. Further write down.
Ma'am, should we write?
Yeah, you are supposed to write.
Okay, ma'am.
Have you noted?
Yes.
No, ma'am.
Be quick, please.
Okay, ma'am.
Yes, ma'am. Noted.
Ma'am, over. Ma'am, over.
Noted. Should I stop sharing?
Yes, ma'am.
Yes, ma'am.
You share another screen. Let's give a quick reading to these properties, because few properties needs to be explained. If suppose the question is asked to you that how can you justify that volume of solids is fixed? How will you justify? Can anyone tell me? We know that its volume is fixed, but what is the reason and how to explain? So, Adyakshan, can you please start reading?
Ma'am, from
Hmm.
where?
Can you please start reading this part?
Okay, ma'am.
Dear, speak loudly,
Reason.
Adyakshan. You're supposed to speak loudly.
Reason. The dif
We cannot hear you. Can others hear Adyakshan?
No, ma'am. Is muted.
Harshit, you start reading.
Hello, ma'am. Now you can hear me?
Yeah.
Should I start reading?
Yes, Harshit, please start reading.
Reason. The definite shape and volume of solids can be explained on the basis of kinetic theory of matter. In the case of solids, the kinetic energy of molecules is least, and the force of attraction between the molecules is highest. The molecules of the solids can just vibrate about their mean position, but cannot migrate from one position to another. Thus, the solids have definite shape and volume.
So similarly, if you have to explain it for liquids, we know that when we put water in a pan on to boil, after a while, when it has gained enough heat energy, it starts boiling and it shows random motion. It shows motion, the topmost layer. Okay, and after a while, like yes, it definitely makes movement on boiling. So for liquids, we can write it molecules of liquids not only just vibrate, but they move from their mean position. Okay, they start showing the movement, and thus its volume is fixed, but its shape is not fixed. Okay, but in case of solids, because the kinetic energy of the molecules is least, because of the tight packing of the molecules in force of attraction is the highest. That's why we can justify that solids. This is because only solids have the definite shape and volume. Understood?
Yes.
Next,
Ma'am.
rigidity. Solids are generally rigid. Almost same explanation will be there. Okay. Just hold on. Next is, just a second, please. See the fifth point, effect of heating. See the fifth point, effect of heating. Triloki, speak loudly, the effect of heating.
Yes, ma'am. Effect of heating. Solids expand on heating, but the dimensions of solids do not increase or decrease in large proportion on heating or cooling respectively.
Okay, so solids expand on heating, but its dimensions do not increase or decrease. So that's why we observe that they have the least kinetic energy. So some example of solids, although you better know the example of solids already. All the metals, wood and wood products are the example of solids. Next, come to the liquids. Neha, read about the reason of shape and volume of liquids.
Yes, ma'am. We know that kinetic energy of the molecules of a liquid is very large, and so is the distance between the molecules. Thus, the attractive forces between the molecules of a liquid are small as compared to the solids. Therefore, the molecules of a liquid are free to move about within the liquid, and hence the liquid can easily take the shape of a container in which it is present. However, the volume of the liquid does not change because the molecules do not leave the liquid.
I hope this is also clear. If any doubt, anyone tell me. Any doubt in the explanation? No, okay. Effect of heating. Yeah, see the effect of heating in liquids. Liquids expand on heating. They expand far more than solids on heating because of the motion they show this start exhibiting, and contract for more than solids on cooling. Means because liquid has if suppose we provide heat to liquids, it will expand, means it will start making motion, and the spaces between molecules will start getting bigger, right? But in contrast, if we provide cooling effect to that same liquid, if we bring the temperature down in the same liquid, because the little space got increased in liquids on heating, then in contrast on cooling, that space will get filled up again when we lower down the temperature. So yes, they also, you can say, they compress on cooling or they contract for on cooling. Is it okay?
Like when we boil water,
Yeah.
the bubbles will come out.
Suppose we have kept a pan of water to boil on the stove, and we have covered it with a lid. Okay. After just it starts boiling, we turn off the flame. Then after an hour, what we find that the vapors that got accumulated under the plate, under the lid that was covered on the pan, that water vapors will start condensing back into liquids, and that same droplets will be, falling into the water in the pan only. Means all the steam inside it on cooling, they start compressing and converted into liquid back to the same state, and it will get added to the same pan again. Fine. Is it okay?
Yes, ma'am.
Now see about the gases. We will read about the gases loudly.
Ma'am,
Hmm.
ma'am, can I? Can I?
Yeah, please, Harshit.
Gas is the most energetic phase of a matter commonly found on Earth. The particles of gas, either atoms or molecules, have too much energy to settle down attached to each other or to come close to other particles to be attracted by them. At the microscopic scale, gases have the following properties. Ma'am, should I read the reason?
Ma'am, now can you hear me, ma'am? I am Adya.
Yeah. So if anyone can read the reason for shape and volume of gases also.
Ma'am, can I?
Hmm.
The intermolecular distance between the molecules of a gas are very large, with the result that the force of attraction between the molecules is negligible. Moreover, the molecules have a very large kinetic energy. Thus, the molecules are particularly free to move in any direction and hence can fill any space. Thus, the gases have neither definite shape or definite volume. I'm done.
Yeah. So because intermolecular distances between gaseous molecules are very large, means with the result that force of attraction is negligible. That's why when we provide heat energy, that energy is absorbed by the molecules and they start showing the random motion. Means within a balloon, if we fill the air, it always occupy like spherical, almost spherical shape. Why not triangular? Why not cuboidal, etc.? Because spherical shape has the maximum surface area. So gaseous molecule try to spread as much as possible in all the space that is provided to the gas. Okay. And moreover, the molecules have very large kinetic energy and they are practically free to move, and thus they have no definite shape and no definite volume. So I hope if it is asked to you how to justify that any of the state of matter, why it has definite volume or indefinite volume, you can explain it well, right? Should we
Yes,
move
ma'am.
further? Should we move ahead now? Now we have to move to the change of state of matter. I'm sharing the whiteboard. Just give me a minute. If we want to convert a solid, means a piece of ice, a cube of ice, to liquid state, how can we do that? You have to tell the condition, favorable condition to convert a solid into liquid state.
Ma'am, melting.
Ma'am, melting.
That's the process of conversion of solid from liquid. I'm telling what should be the favorable conditions, means how to do that. Melting is a process, phenomena. It is
Heating.
not
Ma'am,
Heating.
heating, okay?
ma'am,
Because
it's
when we
melting
bring
point.
out
It
the
is
piece of when we bring out the cube of ice from refrigerator to a normal temperature, that actually means that we are trying to raise the temperature of ice, okay? And that means indirectly it means heating only. So yes, by heating we can convert a solid into gas. Now if we need to boil water, sorry, if we want to convert water into steam or water vapor, what is the condition for that?
ma'am,
Ma'am,
boil
we
it
boil it.
to boiling point.
Ma'am, boil it.
Again,
Evaporation.
listen,
Evaporation.
boil or boiling is again the name of phenomena. It is not a condition.
Ma'am, evaporation. Heating.
Ma'am, the
Heating.
temperature should be at the
Heating.
boiling point of the liquid.
Correct. I actually meant to ask that heating is the, or raising the temperature, increasing the temperature is the condition that is required to move from solid to liquid and liquid to gas. Just hold on, let me draw the diagram. We have a solid. To convert it into liquid state, I'll just write down, hold on. For moving conversion from solid to liquid, we need to raise the temperature. I'm just writing in small, you please write the complete word, increase temperature, okay? And for liquid means water state to vapor state or water to gaseous state. Again, we need to increase temperature. Please excuse me for not drawing the perfect straight line. You please draw it. I have tried to make it in triangular shape, okay? Now, if we want to get back from gaseous state to liquid state, what is the condition for that? Okay, before that, name this phenomena of conversion of solid to liquid.
Ma'am, melting.
And from liquid to gas, it is?
Ma'am, evaporation.
Okay. Melting. Okay. And liquid to gas is evaporation, correct? Now, if we are to move from gas to liquid state, then?
Ma'am,
Ma'am,
condensation.
No, that is condensation condition. Listen. Condition for that is?
Ma'am, lowering low temperature. Ma'am,
Like
cooling.
we
Ma'am, low
increase.
temperature.
But with that, we need pressure also, okay? Without just lowering the temperature will not help us to convert gas to liquid or liquid to solid, but we need increase in pressure also. Just give me a minute. In order to move from gas to liquid, we need to lower temperature as well as increase the pressure. Okay, this will help us to get liquid state back from the gaseous state, and the phenomena will be called
Condensation.
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 Correct. I hope you are getting what diagram I'm trying to make, because on pen tab it's not that possible.
Yes,
And again, to get the solid state from liquid state,
ma'am.
Ma'am,
Solid
the
state
same,
from liquid or liquid to solid? Ma'am,
liquid to solid.
freezing.
Liquid,
ma'am, lower in temperature and increase in pressure.
correct, and increase the pressure. And this phenomena is
Freezing.
called
Freezing.
freezing. Very good. And if the two of the phenomena are left, gas to solid directly, and solid to gas directly, without the conversion, without reaching the liquid state, how can we directly do that?
Ma'am,
First, give me one
sublimation.
example of solid conversion to gas directly.
Ma'am, camphor.
Camphor, very good example. So we just need to light up the camphor and it vaporizes. Okay, just hold on. Solid to gas. No, with green color I need to write. Or just do one thing here, just write down the name. Do you know what is the name of conversion of solid to gas?
Ma'am, sublimation.
Sublimation. Ma'am, sublimation.
Yeah, correct. And any example where we get solid from the gas?
Ma'am, nitrogen.
Nitrogen, yeah. Or the example of dry ice as well.
Ma'am,
So
carbon dioxide.
this is known as deposition. This phenomena is called deposition. Okay. Is it clear?
Yes, ma'am.
Before this diagram, you please write one definition also of change of states of matter. Yeah, just single point, make it a bullet point about the change of states of matter. The heading is change of states of matter. Now write a point. The temperature and pressure are two factors. Temperature and pressure are two factors that can change the physical state of matter. That can change the physical state of matter. Now draw this diagram.
Done, ma'am.
Can you say once more?
Temperature and pressure are two factors that can change the physical states of matter. That can change the physical states of matter.
I'm done with both diagram and
Okay.
bullet.
Sorted, everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Fine then. Be prepared for the test, objective test on Sunday. Fine.
Okay, ma'am.
Okay. Bye bye.
Bye, ma'am.
Thank
Have a
you,
nice
ma'am. Have a
day.
nice
Same
day.
to you.
Okay, ma'am. Bye, ma'am. Have a nice day.
Same to you.